Hello friends, welcome to my YouTube channel. Today we are going to discuss very important topic of parametric linear programming, that is linear variation in C, or we can say that variation in the objective function coefficient. First of all, we will discuss what is parametric linear programming. The investigation that deal with the effect of simultaneous, or we can say that continuous changes of all the component of C or B or Aij vector in the optimal solution of the problem is called a parametric linear programming. We had already discussed the changes in C, B and Aij vector in sensitive analysis, but there the changes are discrete and here the changes are simultaneous, or we can say that continuous. This is the difference between sensitive analysis and parametric linear programming. So let us start. Linear variation in C. Today we will discuss linear variation in C. In this case, parametric linear programming problem can be stated as maximum Z, maximum or minimum, which is equal to C plus C dash lambda x, and these are the constant, where lambda is the parameter greater than or equal to delta and less than or equal to phi, where delta is the arbitrarily small but finite and phi is arbitrarily large but finite. Now we will discuss an example on the linear variation in C. Consider the parametric linear programming problem, maximize Z, and these are the constant. Okay, we have to perform the parametric analysis and identify all the critical values of the parameter lambda, or we can say the critical values or range value. Now let us start with the first step. What is the first step? Write in standard form. We have to write these constant in standard form by adding slack variable. Here maximize Z is same. We have added S1, S2 and S3 slack variable, and this is the standard form. Okay, we have Cj plus lambda C dash j. Now from the objective function Cj plus lambda C dash j, the value of Cj are 3, 2, 5 and these values 3, 2, 5 and 0, 0. Okay, and Cj minus 6, minus 2, 5, minus 6, minus 2, 5 and then 0, 0. Now put lambda is equal to 0, solve by using simplex method. We have to solve these all constant by using simplex method. Okay, I had already discussed simplex method. If you want to watch simplex method, I had provided link in the description. Okay friends, I tell you one thing, that if you have any doubt regarding this question, you can ask me. I had provided my WhatsApp number in the description, but I suggest you please watch this video step by step till end. So here I have solved this example by using simplex method and written the optimal solution here, where Cj is equal to 32500, Zj 725120 and Cj minus Zj is this. The optimal solution at lambda is equal to 0 is x1, no x1 here, so 0, x2 here is 100, x3 is 230 and maximum Z is 1350. Now how to find maximum Z? We will put all these values in maximum Z. Okay, here lambda is equal to 0 and x1 is 0, x2 100 and x2 is 100 and x3 is 230, so maximum Z will be 1350. This was our first step. Now we will proceed to the most important step, step number 2 of this question. This is the most important step of this question. To find critical or range value of lambda. Now we have to find critical value of range value of lambda, in which the solution in table 1 remains optimal. We first find C dash j minus Z dash j values. First of all, we will find C dash j minus Z dash j value corresponding to the non-basic variable. Okay, we have to find value of Cj minus Zj only corresponding to the non-basic variable. Here the non-basic variables are x1 and then s2 and s1 and s2. Okay, columns Cj minus Zj, this is equal to C dash j minus C dash b yj. Okay, here C dash j is here. Okay, now we have to write only those values which are corresponding to x1, s1 and s2. Corresponding to s1 is -6, so I had written here, and then corresponding to s1 column is 0, so I had written here, and corresponding to s2 is 0, so I had written here. Okay. Then c dash b. What is c dash b? C dash b is the value corresponding to the basic variable. Okay. Here the basic variable are x2, x3 and s3. Okay. So I will write the value corresponding to x2, s3 and s3. Corresponding to x2 is -2. So I had written here. Corresponding to x3 is 5. And corresponding to s3 is 0. So I had written here 0. Okay. Then yj. Yj is the column of non-basic variables. So the column of non-basic variable is x1, that is -1/4, 3/2 and 2. So I had written here -1/4, 3/2 and 2. Then the second one is s1. So s1 is 1/2, 0, -2. Then s2. S2 is -1/4, 1/2 and 1. -1/4, 1/2 and 1. Okay. Now I will multiply these two. Okay. After multiplying, I will get this result. That is, if we multiply -2 -1/4, I will get 1/2. Then plus 5 multiplied by this, then 0 multiply, and then in the same way other. Okay. And after subtracting these two value, I will get -14, 1 and -3. These are the value of Cj minus Zj corresponding to the non-basic variable x1, s2 and s1 and s2. Now, for a maximization linear programming problem, the current solution will remain optimal if all Cj lambda minus Zj lambda, that is C dash j minus Z dash j, less than or equal to 0. Okay. Here, the solution will be optimal if these all values are less than or equal to 0. But here this value is greater than 0. That is C dash 4 minus Z dash 4, which is corresponding to S1, that is fourth column, because S1 is in the fourth column. Okay. The first critical value of lambda. So we will find the first critical value of lambda given by lambda 1 is equal to minimum minus Cj minus Zj, C dash j minus Z dash j, but these values should be greater than 0. Okay. Minus C. Here we have taken the fourth column, that is C4 minus Z4, which is corresponding to S1. Okay. And C dash 4 minus Z dash 4. Here C4 minus Z4 from the table. That is 4, 1, 2, 3, 4. Fourth column is -1. Okay. So I had written here -1 divided by C dash 4 minus Z dash 4. Here C dash 4 minus, that is corresponding to S1 is 1. So I had written here 1. Now this means that for lambda 1 belongs to the interval 0 to 1. Why this interval? Because I had taken the value of lambda. First I take the value of lambda is equal to 0. Then I get the value of lambda 1 is equal to 1. So I get the required interval 0 to 1. This means that for lambda 1 belongs to 0 to 1, the solution in the table T1 remain optimal. Okay friends. The objective function value in this interval is given by. Now we will find the objective function for this interval. Okay. The method is z lambda is equal to z plus z dash lambda. Okay. Now the value of how to we will find, as in the simplex table, we find the value of z is equal to coefficient of the base into solution values plus z lambda c dash b into solution values. Okay. Now CB. Here from table 1, CB, that is 200, 500, and after simplifying this I will get Z. Okay, so I had written here 1350. Now C dash B into XB. Here C dash B is -2, 5 and 0. Okay, and I had written here, and XB are 100, 230 and 20. I had written here -2, 0, 5, 0, 100, 230, 0. After simplifying, I will get 950 lambda. Now we will proceed to the step number 3. For value of lambda other than 0 in the interval 0 to 1, we already had checked the value of lambda at lambda is equal to 0. Now we will check the values of lambda other than 0 in the interval 0 to 1. We compute Cj lambda minus Zj lambda values. But for non-basic variables only. Non-basic variables are x1, s2 and s1 and s2 from here. X1 and s1 and s2. So I will write here Cj minus Zj. J are 1 first column. So I had written here C1 lambda minus Z1 lambda, which is equal to C1 minus Z1 plus lambda C dash 1 minus Z dash 1. Okay. Here C1 minus Z1 is from table is minus 4. So I had written here minus 4. Okay. Then C dash 1 minus Z dash 1 from here is minus 14. So I had written here minus 14. Okay. This should be less than or equal to 0. As I had already told you that the solution will remain optimal if Cj lambda minus Zj lambda less than or equal to 0. And after simplifying this, I will get lambda greater than or equal to 2 by 7. Now for the variable s1, this is corresponding to the s1 is corresponding to the fourth column. So I will find C4 lambda minus Z4 lambda, which is equal to C4 minus Z4 plus lambda C dash 4 minus Z dash 4. Now C4 minus Z4, that is 4 is minus 1. So I have written here minus 1 plus C dash 4 minus Z dash 4 corresponding to S1. I had here 1. So I will write 1. And after simplifying, I will get lambda greater than or equal to 1. Now I will find corresponding to S2, which is fifth column. S2 is in fifth column. Okay. So I will write here C5 lambda minus Z5 lambda, which is equal to C5 minus Z5 plus lambda C dash 5 minus Z dash 5. Now C5 minus Z5 from the table 1 is minus 2. Okay. So I have written minus 2 minus Z dash 5 minus Z dash, C dash 5 minus Z dash 5, which is minus 3. Okay. So I had written here minus 3 lambda. After simplifying, lambda is greater than or equal to minus 2 by 3. Okay. Now, first of all, I will write the optimal solution for any value of lambda in the interval 0 to 1, because in the interval 0 to 1, our solution is optimal. So I had written in this table. This table is same as I had already plotted table 1 of simplex method. Only the addition is of C dash j, which are the values corresponding to Cj, that is minus 6 minus 2 5 0 0. Okay, minus 6 minus 2 5 0 0. Okay, and C dash j minus Z dash j. How we will find? After writing C dash b. What is the C dash b? C dash b is the coefficient of the base. Okay, coefficient of the base here is x2, x3 and s3. S2 corresponding to S2 is minus 2. So I had written here minus 2. Corresponding to x3 is 5. So I had written here 5. And corresponding to s3 is 0. So I had written here 0. Okay. Now we will find C dash j minus Z dash j. The process is here. These values multiply by this, as we do in Cj minus Zj as a simplex table. Minus 2 minus 3, that is minus 6 minus 4 minus 2 into minus 1 by 4, then this and then this. Okay, after simplifying I will get minus 14. But in this table I had already found the value of C dash j minus Z dash j, which are here minus 14, 1 and 3. Minus 14 is corresponding to x1, 1 is corresponding to s1 and minus 3 is corresponding to s2. So I will write minus 14 corresponding to x1 and 1 corresponding to s1 and minus 3 corresponding to s2. Okay, and Cj lambda minus Zj lambda, these are the values. Here I have already found C1 lambda, okay, which are minus 14 minus 4 minus 14 lambda. I will write here, and then corresponding to s1 is minus 1 plus lambda. So I will write here, and corresponding to s2 lambda I will write minus 2 minus 3 here. Okay, now we will proceed to the step number 4, that is we will find the improvement of the range. Okay, at lambda is equal to 1, if we put lambda is equal to 1, in these values, here are the values for non-basic variables. Okay, if I put lambda is equal to 1 in this one, okay, that is corresponding to S1 in fourth column, I will get 0. Okay, no problem. But if I put lambda greater than 0, I will get C4 lambda minus Z4 lambda strictly greater than 0, which is against the optimality criteria. So our solution will not remain optimal. Okay, we now enter variable S1, which is corresponding to C4 lambda minus Z4 lambda in the basic by minimum ratio criteria, as we do in simplex table. After finding minimum ratio, in the same way we will enter S1 into the basis. Okay, like this is the table, and S1 is going to be entered into the basis. Now we will find the minimum ratio. How we will find the minimum ratio? Solution values divided by this column. I will get 200, then not defined, and then negative value, which we will neglect. So this is the required minimum ratio. So S1 is going to be replaced for S1. Okay, so S1 will enter in place of X2. Okay, here we have to make the identity column in S1, that is 1 0 0. In order to obtain 1 here, I will multiply by 2 by 1. After multiplying whole row by 2 by 1, I will get here 1, and here I will get 200. Here I will get minus 2, minus 1 by 2, and so on. Okay, and then I have to make here 0. This is already 0, so no change. And then I have to make here 0, so I will multiply this by 2. Okay, then subtract, sorry, add. Here is already minus 2, so I will add this and this row. Okay, I will get the desired result. This is the same as we do in the simplex table. Okay, this is nothing to be worried. Here C dash J is same. Okay, and C dash B is little bit changed, that is S1 column. Here the S1 is, for S1 the coefficient is 0. Okay, x3 5 and x3 0. Okay, now we will find Cj minus Zj. Okay, Cj, as we already know that how to find the Cj minus Zj in simplex table, that is we multiply this and this and this and subtract from Cj. Okay, now in the same way we have to find C dash J minus Z dash J, but we have to only use C dash B and C dash J. Okay, this is very little slight change in finding Cj minus Zj and C dash J minus Z dash J. Okay, these are the required values. Okay, now C dash J lambda minus Z dash J lambda, we are checking the critical value at lambda is equal to 1. So I will put lambda is equal to 1 in the table 2. Here for lambda is equal to 1, I will get minus 18. Then for lambda is equal to 1, I will get 0, lambda 1 minus 2, minus 5. Okay, this is the required table. Now we apply the same procedure. This solution will be optimal if Cj lambda minus Zj lambda less than or equal to 0. Here J is first, second and fifth column, that is x1, and second column x2, and then fifth column, that is x2. Okay, which are not in the basis. Corresponding to x1, C1 lambda minus Z1 lambda, C1 minus Z1 plus lambda C dash 1 minus Z dash 1. Here C1 minus Z1 is minus 9 by 2, and C dash 1 minus Z dash 1 is minus 27 by 2. Less than or equal to 0. After simplifying, lambda greater than or equal to minus 1 by 2. In the same way for x2, here values is 2 and minus 2, lambda greater than 1. Okay, in the same way for s2, which is corresponding to fifth column. Okay, the values are minus 5 by 2 and minus 5 by 2. Okay, which is less than or equal to 0, lambda greater than or equal to minus 1. Okay, therefore for lambda is equal to 1, Cj minus Zj less than or equal to 0 for all non-basic variables. Okay friends, column, and hence the solution is optimal. For lambda is equal to 1, we have required, this is the required optimal solution, and this is the maximum Z. Okay, how we will get maximum Z? By putting lambda is equal to 1 in the above table, in the table 1, that is here. Okay, I will get maximum Z and value of x1, that is 0, x2 is 0, and x3 is 230. Now we first of all check the improvement of solution for lambda greater than 1. Okay, now we will check the solution for lambda less than 0. For lambda less than 0, we have the value lambda greater than or equal to minus 2 by 3. So we will check the value for lambda less than or equal to minus 2 by 3. Okay, so step number 5 is, for lambda less than or equal to minus 2 by 3, Cj minus Zj is greater than 0. If I will put any value less than minus 2 by 3, here I will get C5 lambda minus Z5 lambda greater than 0. So the solution will not remain optimal. So basic variable S2, which is corresponding to this value, that is C5 lambda minus Z5. Corresponding to C5 lambda minus Z5, we have the variable S2. Okay, so S2 is going to be entered into the basis. Now here is one thing to be remember, that we will make any change in table 2, not in the table 3. Okay, here this is the table 2. This is the table 2 which was the optimal solution for this interval, because we are checking improvement in this interval. Okay, so I will make any change, that is I will enter S2 in this table. Okay, not in the third table. Okay, here S2 is going to be entered in place of, by using minimum ratio criteria, S2 will enter the minimum ratio I will get corresponding to this, that is S3. That is S2 will enter into S3. Okay, as in the simplex table. So I had discussed this table. This is the required table as I do in the simplex table. Now here I had found Cj minus Zj and C dash j minus Zj as by this procedure. Okay, and Z, how I will find the Z? This is already I discussed. Z lambda is equal to Z plus Z dash lambda. Okay, by using this procedure I will get Z is equal to 1310 bar plus 890 lambda. Okay, the same procedure, the above solution will remain optimal if Cj lambda minus Zj lambda less than or equal to 0, J146, all the values which are non-basic variables. Okay, I had calculated all these values. Okay, that is C1 lambda minus Z1 lambda and so on. Okay, I will get lambda greater than or equal to, these are the values. Okay, now I had checked the value of lambda for left hand side of this interval and right hand side of this interval. Okay, so for lambda minus 1 less than or equal to minus 1, so here I had get the value of lambda, that is minus 1, and the highest value is minus 2 by 3. Okay, sorry, this is not highest value, this is the value for which I am going to check the critical point. 3, the optimal solution is here in this table. The optimal solution corresponding to x1 is 0, x2 1 by 105, x3 is 220. Okay, and the maximum Z is here. Okay, hence table 1 to 4, all the table from 1 to 4 give family of optimal solution. Okay, this table gives, all the table solutions runs between minus 2 by 3 to 1. That is the value of lambda is from minus 2 by 3 to 1. Okay, in the second table is lambda greater than or equal to 1, and in the last table is minus 1 less than or equal to lambda less than or equal to minus 3. Okay, and the critical value is the values of lambda for which we had checked the range. Okay, that is minus 2 by 3 and 1. This is the required answer for the variation in the objective function coefficient. Friends, if you like this video, please share this video for all with all your friends and subscribe my channel. Thanks for watching.